Good morning. In this video we are going to concentrate on the topic lattice structures, realization in IIR systems. IIR means infinite impulse response. We have seen the lattice structure in FIR system in the previous video session. So now we concentrate on IIR system lattice structure realization. So here actually it has two different types. That means general form of H of Z is in the IIR. It is system function of an IIR system. So it has the numerator and denominator polynomials. I am using these symbols here. Cm of k, z power minus k. So here k is 0 to m. Now here is 1 plus summation k1 to n a n of k z power minus k. So here let it be Cm of z, and this is nothing but let it be a n of z. So that means if I consider the system function of IIR system like this, this form. So here if I consider only all pole system, like, so there are no zeros, such that the equation becomes like this. Simply 1 by a n of z, right? So if I consider zeros also, the system function is nothing but in this manner. It is said to be pole zero system. Pole zero system, right? So if you have only this one, this part, only zeros, that means all zero system, it is said to be FIR system. All zero system is nothing but FIR system. We have seen that one in the previous video. How we can realize that FIR system, all zero system, by using this lattice structure. Okay, now here we just split this one into two categories. One is the all pole system, there are no zeros, and consider the zeros also, that is nothing but pole zero system. Consider this is the first case, and this one is the second case. Now here to realize this one, here firstly we realize this one, that is called as lattice filter or lattice structure. Okay, now the second one is nothing but, if you include the pole zeros in the particular all pole system, it becomes lattice ladder system. Lattice ladder filter or system or realization structure. Okay, so now that means we have the two realization structures here. The first one is lattice structure suitable for the all pole system, and second one is lattice ladder structure suitable for the pole zero system. in the IIR system. Okay, so these two are related to the IIR system realization structures. Okay, so now here firstly, if you consider all zero system, right, that is nothing but FIR system. First, to realize the lattice structure for the all pole system, we take the all zero system in the case of FIR system, right. So just observe this one, and then if I reciprocate or inverse this all zero system, it becomes all pole system. So now by taking this one, by taking the all pole system input output relationship, by converting this all pole system into the all zero system, by observing these two, so from the knowledge of all zero system or FIR system lattice structure realization, we realize this all pole system. Okay, and then from the all pole system, by adding the zero here, what is that, zeros, numerator polynomials, here we just develop the lattice ladder structure. That means firstly we observe the direct form structure for the pole zero system. In that case, we just take the all pole system lattice structure realization. We just combine that one with the ladder structure. That means from the direct form structure. That means the combination of lattice and direct form is said to be here lattice ladder structure. Okay, very simple. If you understand the FIR system lattice structure, this IIR lattice structure is very easy to understand and to implement. Okay, now see this how we will start. Okay, now first one is the lattice structure. That means all pole system. Consider all pole system with the system function h of z. Consider only the denominator 1 plus summation k1 to n a n of k z power minus k, that is equal to 1 by a n of z. Now, so here we just observe what is the direct form realization, and then what is the lattice realization. Okay, so as in the previous case, we just first focus on general form, then lattice form. Okay, direct form realization. So what is the direct form realization here? So see this is also equal to y of z by x of z. So develop the equation for the y of z. So y of z into, right, y of z into 1 plus summation, this one is equal to x of z, and write the equation for the y of z, that is equal to x of z minus y of z summation k1 to n a n of k z inverse. Now from this y of n is equal to, I am not expanding, directly I am taking. So y of n is equal to inverse Z transform. So now here this is nothing but summation k1 to n a n of k, y of z into z inverse is nothing but y of here this one. So okay, here is a minus k, right, here minus k, right, y of z into z power minus k is nothing but y of n minus k. Okay, right. So now, so let it be, this one is equation B and this is equation A. Okay, right. So this is the equation here. So to realize this one, of course expand this and then analyze. Actually no need to write, then you just imagine like this, okay. Otherwise, if you feel any confusion, write, okay, in this form. Now this is nothing but what is that? A n of 1, a n of 1 y of n minus 1 minus a n of 2 y of n minus 2 and so on, minus a n of n y of n minus n. Okay, so now here, so observe this and then implement in direct form realization. That is nothing but here, and there is just take here a direct form realization for IIR system. So there of course you know that consider that form 1 and form 2. Here consider only form 2, and then here there are no zeros, that's why only consider poles. That means you know that structure here in the middle unit delays are there, and then here left side right side summers, in between summers and unit delays multipliers, right? So we have drawn like that. So now in this in the particularly vertically, so now here just draw that one in same thing, but draw that one horizontally, and then here there are no zeros, that's why here concentrate on poles, means you just draw the one side, right? So one side only. So that's why here, see here how can I draw this one. So but there is no difference here, I just draw this one in horizontally, not in vertically. Okay, so now say this. Okay, here I am first placing the summers, and then here x of n y of n is nothing but unit delays so this is y of n, here z inverse, that means here this is z power minus 1, now minus 2 and so on. Here is a z power minus n, like that. Okay, so capital N, z power minus capital N, since here k is equal to 1 to n, that's why. So now add this one with the x of z, and then here the multiplier is a n of n, right? Now here use the multiplier. Like this, and then use the adders also here. This one, right? like this. Okay, so now, so in this way, this is nothing but direct form realization for all pole system. Okay, now to find out the lattice structure here, so now here take the y of n. What is the y of n? X of n minus summation k1 to n a n of k y of n minus k. And then here use the minus values also here. Of course, know this inverse the sign. Okay, right, minus here. Then just to take the what is that resemblance from the FIR system, all zero system realization. What is that lattice realization structure? Here I just interchange. It's a very important point here. Interchange x of n and y of n here. Just interchange. By interchanging here, so what is that? Here is x of n, here is a y of n minus summation a n of k, here is x of n minus k. Okay, so now here what is the y of n? X of n plus summation k1 to n a n of k x of n minus k. Now what is the h of z from this? So that means, of course, you know that this one describes FIR system. Am I correct? It depends on only the present input and past inputs. So but in FIR system, output depends on present and past inputs and also past outputs. If it depends on only past inputs, present input not on past input along with the past output, and then if it does not depend on past inputs, it is said to be all pole system. If it depends on past inputs also, that is said to be pole zero system. Okay, that is the difference. Now here it becomes, by interchanging x of n and y of n in this all pole system, it becomes the all zero system, and that too FIR system. It depends on only present input and past inputs. Okay, see this, right? That means here the system function is h of z is equal to 1 plus summation k1 to n a n of k z power minus k. Let it be a n of z. Actually we assumed like that. So that means here I am directly I have written directly there. That means here y of z, apply the z transform on both sides. Here x of z plus summation a n of k z power minus k x of z. Common the x of z and then take the ratio y of z by x of z, that is equal to 1 plus summation k1 to n a n of k z power minus k. Am I correct? This one. Okay, right? So that means here this is the system function. So okay, here actually we have taken h of z is equal to 1 by a n of z. By interchanging x of n and y of n, we can get h of z is equal to a n of z, right? So that means here based on this point here, we just consider, what is that? Here see, for IIR system, here FIR system. IIR system, we have started with this one. Okay, by interchanging input and output, in the FIR, it becomes FIR system. That means AN of Z. That means one system can be obtained from the other simply by interchanging the roles of the input and output here. Okay, right now, and of course you know that in FIR system, X of n is F naught of n. Am I correct? And Y of n is Fm of n. Okay, we have taken like this. Okay, and in IIR system, X of n is interchanging X of n and Y of n. Am I correct? So by interchanging, so here you can get the realization structure. Okay, in the same manner. So here we are interchanging input and output. Now IIR becomes FIR. So now from the knowledge of FIR lattice structure, you just find out the realization structure for the IIR in the lattice form. That's why here just interchange the input and output in FIR, then you can get the IIR. Okay, like that. X of n means here Fm of n. Let it be here Fn of n. Here m is equal to n. Let it be. Okay. Now, what is Y of n? F naught of n. Okay, right? So, any confusion here? So, there is no confusion. So, just think like that. So, if I take IIR system, right? If I in FIR, Fm of n is equal to, already done in the previous video, Fm of n is equal to Fm minus 1 of n plus Km Gm minus 1 of n minus 1. But in IIR, as interchanging input and output, so now this one is nothing but m minus 1 of n is equal to Fm of n plus here minus Fm minus 1 of n is equal to Fm of n minus Km Gm minus 1 of n minus 1. Here m is n minus 1 and so on 1. That means descending order. So here, since from X of n, what is X of n here? Fn of n. But in the FIR, X of n is F naught of n. To reach Y of n, what is Y of n? F naught of n. In the case of FIR, that is Fm of n or Fn of n. So to reach F naught of n from Fn of n, so we should decrease the order polynomial, right? So that means here descending order, what is that? Fm of n. The set of Fm of n should be determined. It should be determined. Right? So from X of n to Y of n, actually if you use F naught of n as X of n, Y of n is the Fm of n or Fn of n, you just increase the, what is that, Fm of n from F0 of n, F1 of n, F2 of n and so on as in the FIR. But here in IIR we just interchange the input and output, then FIR becomes the IIR. So here x of n is fn of n, y of n is f naught of n. So what is that? Here we have to reduce this fm of n, right? So fn of n, next fn minus 1 of n, next fn minus 2 of n, and so on, f2 of n, fn of n, then f naught of n. That is nothing but our f of n. Okay. So now conclusion is here, Gm of n equations. I am writing equations here from the IIR, from the what is that, FIR, Km Fm minus 1 of n plus Gm minus 1 of n minus 1. Here also m is equal to n comma n minus 1, 1. Now what is the Fm minus 1 of n? Already written in the previous slide, minus Km Gm minus 1 of, what is that, n minus 1, small n. Minus 1. Here also m, n to 1. Then Fn of n is x of n, y of n is nothing but f naught of n, which is also equal to g naught of n, that is equal to y of n. So these are the equations used to realize the lattice form for the IIR filter. Okay, that means here we just considered all pole IIR system, that's why. So now based on those equations we are realizing the structure. What is that? Lattice structure for an all pole IIR system. Okay, right? So just practice the equations, then just reverse the lattice structure as in the FIR system. Okay, right? So first carefully understand the FIR system lattice structure form, then it is very easy to understand the IIR system. So now observe this one. Just reversing nature of the FIR system lattice form. So there actually like this. So here Z inverse. Now here is a adders. Now here like this. Am I correct? This is K1, K1 like that. This is Z inverse. This is nothing but output or Fm of n, and this is Gm of n, and this is F naught of n. This is G naught of n. Okay, right? So in this way you can add these type of lattice structures, cascade these type of lattice structures, then you can get the M stage filter, right? FIR filter. So now here, so coming to the lattice form. So lattice form means here just backwards. That means Fm of n is the input side, F naught of n is the output side. That's why here we just reversing this one. So first use the adders, then use the delay. Okay, right, like that. So observe here. Okay, so based on this structure, just reversing this particular lattice structure in the FIR, we just reversing this one. Okay, so now see how we draw this one. Practice this one. And this is actually x of n input. What is input? Fn of n. Now here this is the delay Z inverse, and here is the point. What is that? Fn minus 1 of n. Here is the point, here is the point Gn of n. Gn of n. Now here multipliers. Here is a Kn. Okay, here is Gn minus 1 of n or Gm minus 1 of n. So here I am drawing n stage filter. F naught of n is nothing but, what is that? G naught of n. Okay, right. So now here in the same way you can develop the two-pole lattice structure. And then here, what is the formula here? So here for IIR system, this one, y of n is equal to x of n minus a n of n, y of n minus 1 minus a n of 2, y of n minus 2, and so on. First here single pole, what is that? Single pole realization means here single stage realization is nothing but y of n is equal to x of n minus a n of n, y of n minus 1. Okay, right? So remember that. So now here now coming to the pole 0 IIR system. Pole 0 IIR system, and here it is also called as lattice ladder structure. Lattice ladder structure. So now here h of z is equal to summation k0 to m Cm of k z power minus k divided by 1 plus summation k is equal to 1 to n a n of k z power minus k, which is equal to Cm of z divided by a n of z. Then here direct form to realization. Actually we used direct form to realization structure to implement this type of pole 0 IIR system. That is nothing but, of course you know this in vertical form. Here I am drawing horizontal form, so don't confuse. Then here see here the structure, how we realize. Z inverse, Z inverse, Z inverse, here Z inverse. So already drawn in this one in the previous videos we have the discussion. So now if you have any doubts, just check that one. For recalling only, here I am drawing like this. Okay, right? So here this is nothing but Cm of 0, this is Cm of 1, and this is Cm of 2, and so on. Here this is Cm of m minus 1, this is Cm of m. So we may use any notation here, C, A, like that, any notation, use any notations, A1, A2, Am minus 1, Am. Okay, right? So in this way, just realize this type of pole zero IIR systems. So these are said to be direct form to realization. Okay, right? So but now here, how can you use the how can you realize this type of pole zero IIR system in the lattice form? So already done in what is that all pole zeros, all pole system, all pole IIR system, and then all zero FIR system also. Now pole zero IIR system is nothing but here is a combination of this direct form 2 and the all pole system lattice form. So now here that is said to be here lattice ladder structure. You just here use upper part this one. This is related to the all pole system. So here you just realize this one with the lattice form, and then remaining part is the similar way you just develop this one. Okay, right? So by using this one, now see this, how can you draw this lattice ladder structure, lattice ladder structure. So now here first draw the lattice forms. How? First summers, next delay units, like this, right? Now and so on. Here same thing. In this way, right? So you know that this is the x of n, that is nothing but fn of n, and here use the multipliers, like k1, kn, kn minus 1, k2, k1. Okay, right? It is in forward direction, so this is in reverse direction. These are delay units. Delay units. Then here is a f0 of n, and this is a g0 of n. So now here see this g0 of n. So here just take the just here consider these multipliers, and then take the summers. Okay, so here is and so on, and here you can get the output. This one is for all what is that, zeros in the system. So consider those are as Vn, Vn minus 1, V2, V1, V0, like that. So now here you can get the output. Okay, right? This is said to be here, what is that? Lattice ladder structures. Okay, right? Thank you.